welcome Patrick.
Thank you, everyone. So my name is Patrick. I'm a technical lead at Haralabidis. I'm also one of the organizers of the Melbourne TensorFlow user group, and I am someone that is passionate about AI and machine learning. But more than anything, I identify myself as a developer. And as developers, when we want to learn new things, what we normally do is we jump in, download our libraries, our tools, our IDEs, and experiment and play with things. So when I decided to understand more about AI and machine learning, though, I found that field a little bit more confusing. There was a whole bunch of new terminology, libraries that weren't very well documented, a lot of academic papers talk about being really good at math, potentially, and statistics in order to do that. And I found that quite challenging. So this talk, I would actually like to show you the approach that you can take as a developer in order to produce something pretty quickly and become productive with AI and machine learning without diving in too much. So if this is your first time actually thinking about doing something with AI and machine learning, or you haven't used it in the past, you're in the right spot. So what we're going to do, we're going to go through a bit of an introduction that we do right now. Then we talk a little bit about the difference between traditional software engineering and AI and machine learning. We'll get a bird's eye view onto what a neural network is and how it works. And then we'll try to put it in practice and use a technique that's called transfer learning that Yasser actually spoke a little bit about before. And we'll try to deploy to a device and see what we can do with that. So we have a bit, I don't know, maybe under half an hour. So the approach I'm going to take is we're going to be a little bit like that. So when we think about traditional software engineering, what do we normally do? We provide input, we write the algorithm for the output, normally in the form of a function, right? We have a parameter that goes in, we write the algorithm, and the output comes out. When we talk about AI and machine learning, this concept is a little bit different. What we do is we provide the input and the desired output, and let the machine learning figure out what the algorithm is, which I find is actually much easier and better because I don't have to do too much. How does this actually work? Well, machine learning traditionally utilizes a thing called a neural network. It is literally just a stack of layers that talk to each other, that they contain math and variables. During the training session, variables get modified, and then until they actually find the right formula to give us back the output. It is literally just like, something like this. Terminologies that you may hear is like features, which refers to input, labels, which is the output that we may give them, and everything in the middle is just a hidden layer that does the math. But how would this work in a traditional problem solving? Well, as an example, last week I was in the US, and anyone that has been in the US will probably know that when you order something at a cafe or a bar, you have to pay a tip in the end. And that tip is not part of the bill, you have to calculate it. It's normally about 18 to 20% or something like that. So I decided that, okay, I'm going to pay 18% and add $1 just to be safe. If we were to solve that problem, if there's not an app or a calculator available, normally we would write a function that would look something like this. It would take the parameter of the cost, multiply that by 18% and add 1 just to be safe. And then it will give us back the amount that we have to pay, which is the total bill. Now, you have to wonder, is this a problem that you can solve with machine learning? Well, I think I'd like us to try. Well, let's try and build the world's tiniest neural network to solve that problem. I haven't rehearsed this, so I'm trying to get this to the right screen. Before I do that, actually, let me just say that as developers, you're probably asking now, okay, how are you going to actually write that model? How are you going to build up the AI machine learning thing? Don't you have to install tools, download different software, use different libraries, right? Well, the answer is yes, but also no. Google has created this wonderful environment that lives in the cloud that is called Collaborative, or short for Collab. It gives us access to TensorFlow, Python libraries, and scientific tools, all for entirely free. So for the purpose of this demo, what I want to do is I have pre-filled what is called the Jupyter workbook, which contains code in Python for our example. And I don't want you to be too concerned about the actual code itself, but more so on the steps that we take to solve it. Almost there. No? that is, sorry about that. Yeah, there we go. Okay, so you can see that very clearly. So, but what will happen is, right now, in order to solve that problem, we have a formula that is the initial cost multiplied by 1.18 plus 1. So how will we solve that in collaborative? Well, what we would do first is initialize our environment. Can you see that clearly? Is that clear?
Can you increase the text size?
Thanks, Alison. And once we have our environment up and running, the first part will be a bit slow. No? The Wi-Fi. I was connected to Wi-Fi, but decided to disconnect me, so. This is going great.
Yes, it is.
That's what I'll keep telling myself. So. Okay.
If you don't mind, can I try that?
Okay, let's try it again. Great. Okay, let's try that. After we initialize our environment, we're gonna import TensorFlow, which is a framework that allows us to perform AI and machine learning training. Which we'll do that here. And add some libraries that will allow us to do some plotting. Right. So,
The second one needs again.
all right. I'm not sure why my screen is not duplicating, so I'm trying to look at the projector while I do that, and it's a little bit tricky. So what we need to do now is we're going to set up our training data, as we said, in order to solve the problem. So what we'll do is we will give the input of the original build that we may have, and also the output, which is the calculation of the 18% plus 1. Great. Now, the next thing we're going to do is we're going to create a model. We're going to create a model that will contain a single layer only, because it's a simple linear formula. We don't need to actually have a very complicated model. And then train it. Right? So the next thing we need to do, actually I still get things to do. Sorry. I'm going to try and solve the duplication of the screens, because it's impossible for me to run the demo without that. Okay. Great. That's it. I've lost more than half the time for my presentation, but hey, well. Okay, so what we did here, we actually define our model, and then we're going to train our model. Great. Now let's see some statistics. What did we actually do? As you can see, we started training that model doing about 500 iterations. But from the graph, you can actually see that after about maybe 50 or 60 cycles, the model became quite accurate itself. So let's try and do a prediction of them. What if we actually receive the bill for $100? Okay, the answer we were expecting is 119, but I don't know if you can see right here. The model now tells us that it is 118.9, pretty accurate, right? So we didn't actually have to define or do much ourselves, apart from giving the inputs and the outputs. But having said that, I think I'm back in track. Having said that, that wasn't too great, right? We didn't really do that much. And it's not really a motivation for us to start looking at AI and machine learning. It's something that we can solve pretty quickly by doing some simple coding. But you've seen some cats and dogs examples. But I would like you to think a little bit about the fact that, well, what if you wanted to build an app that would identify the breed of a pet? How would you even go about it in programming? There's so many different variables. There's so many different things to consider, right? The shape, the image, the color, the type. It's almost impossible to write it like that. And that's the reason why we use machine learning. So what if we really wanted to build an app that works like that? How would we even go about it? Well, the first option would be to think about it and say, okay, great, now we have to actually start sourcing all the data, try to figure out the model, train it, spend a lot of time refining it and tuning it, and then, like maybe potentially start evaluating how good that would work. But there is an easier way. There is this practice called transfer learning, by which what we do is we define the input and take already a predefined and fine-tuned model. We freeze the middle part of the model so that it doesn't change at all, and then we just simply change the output. So technically what we're saying is like, we're going to take a model that can identify images and work with images really well, and we're going to feed it our own data and our own desired output. Where do we find that model? Well, TensorFlow Hub already has a massive collection of predefined and pre-trained models that allows us to work both with images, text, and video. And what about data? Do we have to sit and collect the whole thing ourselves? How do we even go about finding all those datasets? Well, I'll say start with Kaggle. Kaggle has a great amount of datasets. And also, there's also TensorFlow datasets, which I prefer quite a bit because they're really actually quite well integrated within the Python notebooks themselves. Now, we said we want to deploy that onto a mobile device, right? But models traditionally get served on a server. They require a lot of power. They potentially require quite a lot of GPU capacity. Utilizing TensorFlow Lite allows us to take a framework and compress it and make it, like suitable for low power, low GPU, low capacity devices, which we're going to use as well. So let's see how we're going to do that. So again, I have pre-created a notebook to save us a little bit of time rather than using code that doesn't work. But I want you to concentrate again on the steps. So we'll start again with a simple setup. We're going to select the version of TensorFlow that we would like to use. And more importantly, there's an option in Colab to change our runtime. So now we can define that we would like to use GPU if we're going to train images, or even TPU, and that all still comes for free, which is great. Let's input libraries. And in the next step, what we're going to do is we're going to select our model that we're going to apply transfer learning to. And for that purpose, we have a couple of choices, but the one that I prefer to use is the MobileNet. There's ResNet as well. Again, that was selected directly from the TensorFlow Hub. Now we're going to need the dataset, right? So let's import the TensorFlow Hub datasets here. Now we said we're going to build a pet breed identifier. So for that purpose, I found that Oxford has published a great dataset that contains 37 breeds of pets with 200 images each. So I'm going to download that model and then feed it into our pre-trained model. But because that dataset is actually a whole one, the one thing that we would like to do is split it in 3 parts: 80% for training, 10% for testing, and 10% for validation. So we're going to do that right here. One more thing that we need to keep in mind: that model has been trained with a specific size and depth of images. So it had 224 by 255 by 255 images that have 3 layers, so RGB. So all the images that we have in our current dataset actually have to be formatted to match that. And the next thing that we're going to need to do is define a batch size so that we can do that in batches. So that takes a little bit of time, obviously, because there's quite a few images that it's trying to separate there. The choice of internet connection. Okay. Great, downloaded it. I'll run that again just to be safe. Set the batch size of 32 images per batch. And do that for our, okay, so let's have a look at one of them. So what did we create now? We actually have one batch that has 32 images that are 224 by 224 pixels wide, and they have 3 channels, which is the color channels, the RGB. Now we're going to apply some fine-tuning. I'm not going to go into the details of fine-tuning actually, because we lost quite a bit of time at the beginning. But then what we're going to do is we're going to load the mid layer that we're going to train. And we're going to define how our model is going to look, which essentially is the original model that we had up here. If it's quite visible, so the original layer had 1,280 classes, and all we really did is added the last output layer for us, which is the 37 classes, which is the 37 types of breeds that we would like to do. And then the next thing that we're going to do is train it. So we're going to train it for 5 cycles, which means that we're going to go through each and every image five times. And training does take some time, even though with GPU applied, so that's going to be a bit slow. And while it does that, just to recover a little bit from what we lost before, the next thing that I'm going to do, and I'm going to do it quite quickly, we need to convert that model for mobile consumption using TF Lite. So the next steps in the notebook, which I'll share with you later, and actually you can find quite a lot of examples on the TensorFlow tutorials thing, will do just that for us. Now, one thing that is interesting to look at, while the model is actually training, you can see that right now its accuracy about 73% in its first cycle, and it has a loss of maybe 1%. And you can see that that accuracy is actually growing as it's training, which means that our model will be able to predict more and more accurately, and like as more we feed it the right data and keep training it. I promise it was training so much faster earlier today. Okay, almost there. So you can see we haven't really spent much time. We've actually just been training for what, maybe 2-3 minutes. And you can see that we're getting high percent of accuracy. And that is really because it's the way because transfer learning works. That model is it's almost the same way that probably our human brain works. Once we learn to do something, let's say that we learn to work with RESTful APIs and write applications with those, we may become really good at one because we could learn it. But then if someone gives us another API to work with, we're definitely going to pick up the space much faster and we're going to be more efficient. So the same thing happens here. Okay? Almost one more iteration. This is telling that it has almost 98% accuracy. I don't know if I want to believe that. Great. Almost there. So now we believe we have a model that has, well, technically really high level of accuracy. And we haven't given it that much data, really. We have just provided just a number of images to do that. Great. So the next thing that we're going to do is just export the model. And load it. And have a look what we created. So what we've done here is literally a model that had the original one plus the layer that we added underneath. I may need to fast forward things as well and skip the conversion to TensorFlow Lite. But if we think about it, what did we actually do, right? Well, within maybe 5 or 10 minutes, we took a dataset and a pre-trained model, and we created another one that reached almost 99% accuracy, right? That didn't seem that hard. We didn't have to go out and fetch all that information ourselves. And the code that we've written literally was just a few lines. Well, we need to test it and see a little bit how it actually works. So let's try and load it in an app. So what the exported model that we have is the TF Lite interpreter, which will talk to a data handler, and then of course from that data handler we're going to straight in a view controller. So let's try and do that. I have pre-created a mobile app that looks exactly kind of like this. So within the app, we have loaded our exported model. I didn't export it, but I pre-exported it over here. We have a single view controller and a data handler that does the talk between the model and the view controller. Now if I run this, I have not seen this dataset before actually. I haven't even tested it before this thing. But what we're going to do is by tapping on one of those images, we're going to send it back to the model that we just created and try to see if it can predict. So let's see how well it does. That looks right. That is a Beagle. Samoyed. Ragdoll. That seems pretty accurate to me, right? So it wasn't really, like that hard for us to get from, well, at the start of the talk, where we had absolutely nothing, to almost having an app that can do what we talked about before. Oops, sorry. presentation. Let's go back. Okay. Great. So, in conclusion, well, ML is not that complicated. If you understand the basic steps that you can take in order to produce a model, train it, and then know which frameworks to pick up and use and deploy it, it's actually quite straightforward. We didn't have to know a lot of math. We didn't really have to know the internals of those models and how they behave or how they get trained. If there's any advice from me, I would probably come back and say use transfer learning. Go to the TensorFlow Hub, pick up pre-trained models, start experimenting with them. Go find data sets, explore them, and try to produce solutions of your own. And don't be afraid to, like if you're mobile developers, to delve a little bit deeper into TF Lite and try to produce solutions of your own. Any questions?
Does anyone have any questions? We've probably got time for one question.
It's a really good talk to see how easy it is to get machine learning employed, but I'm being a skeptic for one particular reason. It feels like we're talking about gun control, we're talking about having state agents control ammunition, and now we're saying that we have the ability to democratize access to weapons in every household for some reason. So using transfer learning or approaches like that, that doesn't have explainability to it, that doesn't have the right amount of rigor to understand biases in the system and biases in the algorithm, can be really, really dangerous. So I'm sure that's not what the talk is about. The talk is more about showing that this thing is available for developers. But the point that you make in the beginning that, look, it's so easy, you don't really understand the models, you don't need to understand the map, it's a bit questionable, to be honest.
Oh no, I agree, and thank you for bringing it up. I'm not saying that blindly take and use everything that is given to you, but if you think that you're in a scenario whereby you don't even understand the technology and you want to get started, I think that if you try to take the approach, because I found myself in that scenario as well, of like, I'd like to understand everything about it. I'd like to understand a lot more about how the models work, about how these things, it's hard for you to get productive pretty quickly. So the approach that I'm suggesting here is more for personal education. Try to demystify it, right? Get involved into it. You don't actually have to take a degree in AI, in machine learning, or data science before you can produce a solution for your own purposes, right? We're identifying breeds here, we're not selling any personal information. So that was the whole point. Don't be afraid of it. Go in and experiment with it. And I understand that most of those resources now are available easily and maybe discoverable, but they weren't some time ago. And from my own personal experience, it took me quite a while to find them and be able to produce something. Any other questions? Or do we have time for more questions?
I think we'll wrap it up for now. Thank you so much, Patrick.
Thank you.